So in this video, we are going to see closed hashing. Okay. So in under the hashing heading, we already saw open hashing. Now we are going to see closed hashing. And under the closed hashing, there are three techniques are there. One is linear probing technique. Second one is quadratic probing technique. And the third one is double hashing technique. So all these three techniques are, what is it? The ultimate is we are going to access one data item from the table. So at the time of accessing through hashing technique, the number of access is one only. So that is the most advantage of hashing technique. So under this, when we are storing the information, how we store the information, what are all the problem it arises, how we overcome, so we are going to see in detail. So in this case, in the closed hashing also, we want to overcome the pollution problem. Okay. So if you have any doubt, just you refer my previous video, then you come to this video. Okay. And under the linear probing technique, what is it? Linear probing. The linear probing technique searches for a closest free location. What is it? It searches the closest free location whenever the collision it appears. Whenever the collision it appears. And add the new key into that particular empty cell. So this is what we are going to do. Okay. As example, we take the same example. In this example, we are calculating the memory addresses. Okay. What is it? It is, we call it as index of hash index. Index we are calculating. So here I already executed 3 to 4 data. So how I executed? I am taking this formula. So this is the formula I am taking, and m value is 10 here because we are taking 10 memory location 0 to 9. So that's why m is 10, and the formula is h of k equal to 2k plus 3. So we are using h of 3. We are taking the first data. H of 3 equal to, we are applying with this formula, 2 of 3 plus 3 modulo 10 equal to, what is it? 2 into 3, 2 into 3 6 is 6 plus 3 9. So 9 modulo 10, it is 9. So that's why we go to the 9th location and we store the data key of 3. So I am storing here. And the second one is 2. So h of 2 equal to 2 into 2, we are applying into the formula. 2 into 2 plus 3 modulo 10. So what 2 into 2 4, 4 plus 3 7, 7 modulo 10 it is 7. So we go to 7th memory location, then we are storing the key of 2 there in the 7th location. So like way the rest of the 2, what is it? H of 9, it is the memory location is 1, we go to 1 and I am storing 9 there, and H of 6 is 5, so we go to 5 and we store number 6 there. Okay. So now we are taking the next data. What is next data? It is 11. H of 11 equal to 2 into 11 plus 3 modulo 10. What is the value? 2 into 11, 22, 25. 25 modulo 10, it is 5. Okay. So what happens here means it is 5. So collision it occurs. It is 5. Collision it occurs. Collision it occurs. It means that we go to the appropriate memory area. The memory area already filled. So that's why I am unable to store any item in the filled memory location. So that's why at this situation we take the probing, linear probing. It is probing. It is nothing but we go to the current memory location. We probe it. Probing it means we are advancing it to the next memory location. That's why it is called as linear probing. It is nothing but it go one by one. So linear probing, it is nothing but instead of storing the data into 5, I go to sixth location and I check it out whether 6th location is free. So it is free. So that's why I store number 11 there in the 6th location. This is what the idea. Okay. So this is what we are doing in the linear probing technique. So what is the next number? Next number is 13. 13 means h of 13 equal to 2 into 13 plus 3 modulo 10. What is 2 into 13? It is 26, 29. So 29 modulo 10, it is 9. So 9 again already filled. 9 already filled. 9th location already filled. So that's why what I do? I have to go for linear probing. What is linear probing? After 9th location, what is it? 0th location it comes, because only the memory location from 0 to 9 only. After 9 it directly comes to 0. It used to check it whether 0th location is free. It is free, so that's why I am storing number 13 there in the, what is it, 0th location. 13 goes there. The point here. Then once again we are taking the next number. What is it? H of 7. I think next number is 7. H of 7 equal to 2 into 7 plus 3 modulo 10 equal to, what is it? 2 into 7, 14, 14, 17. 17 means 7. So 7 already there. So it is a collision problem. So we want to overcome the collision problem. We are going for linear probing technique. We go to 7 and we used to take the linear probing next memory location, 8th location. 8th location is free now. So that's why I am storing number 7 there in the 8th location. The one here. Then once again I take the next value. It is H of 12. That is 2 into 12 plus 3 modulo 10. That is equal to 2 into 12. It is 24, 27. So 27 means 7. So 7 already there. 2 times 7 is there. So that's why we are unable to store on the 7th place. So what I do? I have to go for 7th location and I probe one memory location. So what is it? I go to 8th location, it is also full. I go to 9th location, it is also full. I go to 0th location, it is also full. I go to first location, it is also full. I go to the second location, then it is free. So linear probing means we go one by one up until the next free location. So that's why I take the number 12 and I store it in the second location. So this idea, it is called linear probing method. Through linear probing method, we are overcome the collision problem at the time of storing values in the hash table. Is the point clear?